Today we're going to look at solving radical equations. Now, solving radical equations, especially very basic equations, there's really only 3 steps to it. So, step 1 is you're going to get the radical alone. And what I mean by that is you want to get the radical, remember a radical is a square root, you want to get the radical by itself, nothing added or subtracted or multiplied in front of it, nothing added or subtracted or multiplied behind it. Step 2, once you have your radical alone, is you want to square both sides. Because what's going to happen is the square and the square root are going to cancel each other out, and it's going to make a much easier equation to solve for. And our third and final step is going to be to solve for x. Okay. So, if you need to pause the video, go ahead and pause it. But we're going to do a couple basic examples, and then we're going to look at examples that contain some extraneous type of solutions. Alright, so the first one that we're going to look at is going to be 2 plus the square root of 3x minus 2 equals 6. Well, again, step 1 is you have to get the radical by itself. The 3x minus 2 is underneath the radical, so that's part of the radical. Basically, you're looking in front of or directly behind the radical and get rid of anything added, subtracted, or multiplied. So in this case, what we're going to have to get rid of is we're going to have to get rid of this plus 2 in the front. So to get rid of a plus 2, we minus 2 to both sides of your equal sign. So we get the square root of 3x minus 2. Made that one a little long, sorry. In this case, 6 minus 2, which gives us 4. Alright, now our radical is alone. So there's nothing added, subtracted, or multiplied in front of or behind it. So now what we can do is we can square both sides. And what happens is the square and the square root will cancel each other out. So it's just going to be a 3x minus 2. And then 4 squared is 16. And now we're on to step 3, which just means you're going to solve for x. So we're going to have to add 2. So 3x equals 18. Divide by 3. And I get that x is equal to 6. That's as easy as that. So we're going to do a couple more basic ones. Let's say I had a 3 square root of x. Plus 3 equals 15. So in order to solve for x, in this case I'm going to have to get rid of the times 3 in front, and I'm going to have to get rid of the plus 3 that's behind it. Well, just like any other equation, you always get rid of what's added or subtracted first. So we go through and minus 3 to both sides. So I get 3 square root of x is equal to 12. Divide by 3 to both sides, so I get the square root of x is equal to 4. Well, there's the completion of step 1. My radical is by itself. So now I can go through and I can square both sides. And again, the square and the square root are going to cancel each other out. So I get x equals 16, and that's my solution to that one. Alright, so we're going to look at one more of these basic ones, and then we're going to start getting into what's called an extraneous solution, which is pretty much what you're going to have tested in Math 2. So if you need anything from the screen, go ahead and pause the video. Alright, so last basic one we're going to look at is this one. And for some reason, people seem to get these wrong. It's actually an easier question, but people tend to get it wrong. So step 1 is always to get your radical by itself, nothing added or subtracted, multiplied, or in front of or behind it. So if you look at this equation, there's nothing added, subtracted, or multiplied in front of or behind this one. So this one really has no step 1. We just go right on to step 2 and square both sides. So just keep in mind sometimes your radical is already alone, and you don't have to get rid of anything to do that. So in this one, we just minus 3, so I get x is equal to 22. Alright, so now we're going to start getting into something that's called an extraneous solution. So if you need anything from the screen, go ahead and get it, and I'm going to clear it off. Alright, an extraneous solution. Sorry, it takes me a little while to write on here, or at least try to write nicely. Is an answer you have solved for correctly. But when you plug it back in, it does not work. Okay. And these sort of things you're going to see mostly when you start with two x's. Okay. So an extraneous solution, again, is a solution that mathematically, when you solve for, you've mathematically done all your stuff correct. But if you were to plug it back in, it actually does not work. And when we get into the next video, which is going to be graphing radical equations, you'll probably start seeing why some extraneous ones exist. So let's look at one that does have some extraneous solutions. Now I am going to clear the screen, so if you need anything from the screen, go ahead and get it. Alright, so let's look at square root of x minus 3 plus 5 equals x. So again, when I first look at this thing, I ended up having two x's that I'm starting with, one on each side. So more than likely I'm probably going to have to deal with extraneous, and it's true in this one. This one does have extraneous. Your steps are still the same as it was before. You do want to go through and get your radical by itself, so in this one I'm going to have to get rid of this plus 5. So to get rid of that plus 5, I'm going to have to minus 5. So I get the square root of x minus 3 is equal to x minus 5. Can't read my own writing there. Okay, so now my radical's alone, so I can go on to the next step, which just means that I'm going to square both sides. So I get x minus 3, and here's where it starts getting a little funny. On this right-hand side, I'm not just squaring the x, and I'm not just squaring the 5. I'm squaring x minus 5 together. So what that means is I'm going to have to simplify that right side. Remember that square means you want to write it twice. Now, what I've recommended to students in class is I would probably do this part off to the side and then just stick it in the right spot once it's simplified. Because you don't want to write this step multiple times. Remember, x minus 5 squared means it's x minus 5 twice. Okay, so x times x is x squared. Then we have a negative 5x, another negative 5x, and a positive 25. If we combine those like terms, I get x squared minus 10x plus 25. So this is what needs to be over here on this side. And like I said, it's more complicated than the ones we were looking at before. So again, those usually tell you you're probably dealing with extraneous solutions, again, which we are. Alright, so now we have a quadratic on the right-hand side. And when we solve quadratics, we learn that quadratics have to be equal to 0. So the easiest thing to do is to get rid of, in this case, the x minus 3, get rid of that and move it to the other side. The basic general rule is try to move everything to the same side as the x squared. So we're going to minus an x to both sides. We're going to add a 3 to both sides, and if you notice that I'm putting it right underneath the like term, it's just going to make it easier to simplify. Minus 11x plus 28. Alright, so now this quadratic, we have to go through and solve our quadratic. And you guys can solve this multiple ways. You can do factoring, which is probably what I'll do on here, because it doesn't take up a lot of space. You can graph it and find the x-intercepts. That'll find them as well. Or you can use quadratic formula. It does not matter. All three methods will give you the same solution to your quadratic. Again, I will generally factor just because it's faster for me to factor and it doesn't take up a lot of space. Alright, so with this one, if I were to go through and factor it, this would factor to x minus 4. I don't know why I just wrote an extra x. Sorry. X minus 4 and x minus 7. So that means my solutions to this one, remember you do take the opposite sign of what's in there, it's going to be 4 and 7. So again, I have 2 solutions. Now, what we end up having to do is we have to plug them in and check to see which ones work. So sometimes only one of the solutions work, sometimes they both work, sometimes neither of them work. So we're going to go through, and so I'm going to get rid of some of this stuff up here in the corner and just kind of clear that out of there a little bit. Sorry. Now, you don't have to write this stuff. I'm just going to write it as we go through and just kind of check over here. Alright, so there's my original function. I'm going to go through and check 4 first. If I were to plug in 4 and for x, I'm just going to figure out what each side is. This side's easy, that side's 4. If I were to plug in 4 and for x on the left side, 4 minus 3 is 1, square root of 1 is 1, 1 plus 5 is 6. Does 6 equal 4? No. So that 4 is an extraneous solution. That's not actually one of my solutions. So now, I'm going to test out when x is equal to 7. So that side's easy, and plug in 7. On the left side, 7 minus 3 is 4, square root of 4 is 2, 2 plus 5 is 7. So that one does work, which means that 7 is my only solution to it. So on the homework, it's multiple choice. So if you have an extraneous, that's not part of your solution. Alright, so if you need anything from the screen, go ahead and get it. We're going to look at another one. Alright, so let's say this one. We have square root of 3x plus 7 is equal to x minus 1. Again, I'm starting out with 2 x's. More than likely, I'm probably going to have something extraneous. Alright, so again, step 1 is to get your radical by itself. In this case, my radical already is by itself. So I can go ahead and go on to step 2, which just means I'm going to square both sides. So that's going to give me a 3x plus 7 on this side. And I have an x minus 1 squared on this side. So again, that means that I'm dealing with x minus 1 times x minus 1. So if I were to multiply that out, I'm going to save a little bit of step here. It'd be x squared minus 2x plus 1. Again, I have to get everything to the same side as that x squared. So I'm going to minus 3x. And I'm going to minus 7 to both sides. So when I simplify this, I get 0 equals x squared. Oops. It'd help if I actually wrote the problem down correctly. That was a minus 3x. So that gives me a negative 5x minus 6. Again, I will generally factor to solve. So this one's actually going to factor to, looks like x minus 6 plus 1. Let me double check. Yes. So that means my solutions are 6 and negative 1. So those are the two that I want to go through and check. So 3x plus 7, x plus 1. So I want to check each one of them out. So I'm going to try 6 in for x first and just see. Now on this right hand side again is a little easier. That's 7. If I plug in 6 on the left hand side, 3 times 6 is 18. 18 plus 7 is 25. Let's see, hold on. Alright, I see what I did. Hopefully you caught that too. I didn't write my original equation correct. So let me fix that real quick. It does help if you write the equation correctly. Alright, so with this one I'm testing out 6. So if I plug in 6 in for x on this side, that side becomes 5. And if I plug in 6 in for x on the left hand side, 3 times 6, which is 18, plus 7, which is 25, square root of 25 is 5. So that one does work. So now I want to go through and plug in negative 1 in for x and see what I get. Alright, the right hand side again is going to be easier. Negative 1 minus 1 is negative 2. So if I plug in negative 1 in for this one, I get negative 3 plus 7, which is 4, square root of 4, which is 2. 2 does not equal negative 2, so that means negative 1 is an extraneous solution.